Okay, good afternoon class. So today we're looking at probability. You guys had homework on it, correct? Alright. The homework was exercise. Exercise 3. Even numbers. Alright, this is the first of it. This is exercise 3 and this on page 315. Right. The question says 5 people are to be seated in a row. How many ways can they be seated? So how many bids do I draw? 5. How many options do I have for the first bid? 5. Then 2, 1. 5 factorial, which is 120. Is that correct? Yes. B. How many ways are there if 2 of the 5 insist on sitting next to each other in a row? Somebody in the best in, eh? So what we do? We find 2 of them, not so many. So they can sit in how many ways? 2 factorial. Now it becomes 1 bid. So it's 1, 2, 3, 4 times 4 factorial, which is 2 factorial times 4 factorial gives you 48. So 48 ways the combination can be made up. You all agree? You all understand? Okay. Next, number 4. Let's pull this down. Huh? Number 4. We have all 4 history books. 3 geography books must be placed on the shelf. 4 history and 3 geography. Now, how many different ways can you arrange these books on the shelf? How many bids do I draw? 7. So how many options do I have here? 7. Then 6. Then 5, 4, 3, 2, 1. Which is 7 factorial. 7 factorial gives us an answer of 5040. B. If all the history books must be placed next to each other and all the geography books must be placed next to each other, in how many ways can you arrange these books on the shelf? So it's 1, 2, 3, 4, 5, 6, 7. All the history, so H. So that I must bind, not so. What? So they must be together. How many ways can that occur? 4 factorial ways, not so. The geography, geo. We bind them. How many ways can they occur? 3 factorial. And of course, geography can come first as well. Then history. So that's going to be 2 factorial. So it's 4 factorial times 3 factorial times 2 factorial. Gives you 288 ways. Okay. Last one, C. If just the history books are to be together. So this is now C, so it's 1, 2, 3, 4, 5, 6, 7. History books are 4, not so? So that would be, how many ways can that be arranged? 4 factorial ways times. Remember, this we treat as 1 bid now. So it's 1, 2, 3, 4 factorial. Then it will be 4 factorial times 4 factorial answer of 576. Okay. Let's go to number 6. Let's take this out. Number 6. Find the number of ways in which 6 people can ride a toboggan. You know what that is? I think that was the dragon racing, with the dragon boat racing in the... It looks like a canoe. No? You guys know what a canoe is? Yes. Now that is one of those. I don't know how to do this question. Okay. I haven't been on one, so I don't know how that works. Okay. Who got the right answer for this one? You don't know how to do, absolutely not. I haven't been on one, so I don't know. I don't think one can hold me. Right, let's look at number 8. Right, so number 8. This is exercise 3. On page 315. Okay, golf balls are numbered 1 to 12 and placed in the box. Every time a ball is drawn, it is placed on a rack next to one another. Okay, so from a bag or whatever, a ball is drawn and then placed on the rack. Okay, so would this be an example of... No, okay, okay. So here we go, 8A. How many different arrangements of 12 golf balls is possible? How many bits should I draw? 12. So how many options do I have for the first one? 12. Then 11. Then 10. 9, 8, 7, 6, 5, 4, 3, 2, 1. 9, 8, 7, 6, 5, 4, 3. So this is 12 factorial. I think this number is fairly large, no? But you can write it down. So that's 479 million. 479 million. 1,600. Okay. Let's look at B. B. The numbers 1 and 12 must be placed next to each other in any order. How many ways can the numbers be rearranged? So again, we're going to have 12 bits for 12 places. If 9 and 12 has to be together, then what do? You bind them. Okay? So how many ways can that arrangement take place? 2 ways. So it's 2 factorial. Okay? Times. But then again, that can happen there, it can happen there, it can happen there, there. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can you see that 11 there? So it's times 11 factorial. Okay. Which is 2 factorial. 2 factorial is 2 times 11 factorial. It's going to give you 79,833,000. 79,833,000. Okay. Let's look at C. In C we are told and the numbers 1, 4, 5 and 8 are taken from the box. 2-digit numbers must be formed out of these 4 numbers. So how many bits are we going to draw here? 2. Okay? How many number arrangements can be made if the digits may be repeated? If the digit may be repeated. So how many options do I have here? The digits may be repeated. How many options do I have here? 4. Then 4, which is 16 ways. Not 7. Then we are told that digits may not be repeated. So again, 2 bits. How many options do I have in the first case? 4. Then 3, which is 1. Okay. Letter arrangements where the letters are repeated. Did we do this already? No. Alright, there's your new reading. Letter arrangements where letters are repeated. Okay, write that down with me. That was the test today. It's good. I thought I was going to give you like a nice thing so you can start, enjoying maths. Yes, common paper. So it's in the hands of somebody else. Yes? So yeah, how much is this?
How much does this psychologist weigh compared to the other test system?
I'm not sure, I can find out. But the main thing is your 2 papers. But it does count, but not so much. There you go. Are you guys preparing for that exam? Oh, now you'll be like, don't come to the day you write your paper and you say, okay, now I'm going to prepare. No, like you're doing today. No, we're going to. Until you get home and you watch your first Netflix episode or something. And then there goes everything. So make us proud, because now there's a few schools writing the common paper. At least I'm going to say, okay, somebody got 150 out of 150 for paper 1. Isn't that possible? Not possible. I'm going to give you a chocolate, boss. A big one this time. This time. I'm going to give you a small chocolate. Yes. So I don't want you to do the calculation and I know what I'm talking about. I'm a dad, so I can do this calculation. Right, here we go. The letter arrangements where letters are repeated. Okay, this is how this works. We are told that consider the letters of the word dad. They want to know enough. How many word arrangements can be made if the word... No. How many word arrangements can be made with this word if the repeated letters are treated as different letters? The repeated letters are treated as different letters. Which means to say, the one D is different to the other D. Not so? This is example 11 on page. Huh? 317. Hey, last time the thing didn't pick up the mic. Alright. Alright, so let's do this one quickly. Alright. So if you look at this word arrangement here, okay? Let's go with A. So if the repeated letters are treated as different letters. So let's make this dad. So this one way. Let's call D1 and D2. Okay? There's the first D and the second D. Yeah? So that is one way of writing. Another way I can write the same is D2, A, D1. Not so. Give me another way I can write this. A, add, yes, D, D. D1, D2. A, D2, D1, yes. D1, D2, A. D2, D1, A. So how many ways are there? 6 ways. Not so. If I do that by calculation, this is going to simply be, since there are 3 options, it would be, how many options do I have here? 3 then, 2 then, 1, which is 3 factorial, which is 6. Not so. Let's look at the next one. You see here, if there are 3 letters and the repeated letters are treated as different letters. So that one D is different to the other D. No? Right. So then this can be D1A, D2, D2A, D1. So these are the 2 ways. Then that's going to be A, D1, D2, A, D2, D1. Another 2. So it's 4 in total. Then this here would be D1, D2A, D2, D1A. So it's 6 ways. So if you're looking at by calculation, we're not always going to draw this D's, no? And the A's, whatever. Since the repeated letters are treated as different letters, so that is what you're going to look out for in the wording. Repeated letters are treated as different letters. Then it can be for 3 letter words. I got 3 options there. Then 2 options. Then 1 option. That is why it's going to be 3 factorial, which is 6. Okay. Let's look at B. Okay, so this is part of A here.